General Motors Corporation opened its doors to its new test facility here in Yuma only 2 years ago. Follow us as we take a look back on those 2 years and reflect how far we've come. We'll take you inside the facility to see what new and innovative technologies GM is working on today.
We're coming up on 2 years. It doesn't really seem like that long, but a lot has happened in the last 2 years. If you are interested in cars, working at a proving ground like this is a dream job.
For General Motors, the facility they have is 2,400 acres in size. It cost them $100 million to build. It's a state-of-the-art hot weather automotive test facility with test tracks, automotive maintenance bays, and just a lot of just top-notch stuff.
One of the first people we met actually when we started the process of planning the move was Julie Engel of the Greater Yuma Economic Development Corporation. And she just bent over backwards to answer our questions. We came down here several times with engineers and technicians that wanted to become familiar with the area. And that really helped our employees to, and maybe even more importantly, their spouses and so forth, to become comfortable with the move and understand a little bit more about Yuma and some of the opportunities that were here. Julie's efforts were just fantastic.
Privacy was extremely important to them, and that's what attracted them to Yuma Proving Ground, because Yuma Proving Ground owns all the airspace over their 1,300 acres, and so that provided a great deal of security for General Motors, which is what they were seeking.
The clincher for Yuma was being able to do a joint use lease with the U.S. Army here at YPG. That's turning out to be a great deal for both GM and I think also for the Army.
We're really happy to have established this partnership agreement with General Motors because what it really is it represents a win-win for both organizations.
The first automotive proving ground in the world was built by General Motors in 1924 at Milford, Michigan, near Detroit. Vehicles were simpler then, and so was the testing. Today, testing is extremely complex. Because vehicles have become so complex and because the customer demands transportation that is dependable, economical, and comfortable, as well as safe and environmentally acceptable. Meeting these demands has required dramatic changes in automobile designs. Recent trends have been toward development and use of advanced electronic monitoring and control systems.
Well, what we've really been doing the last 2 years, we made a lot of improvements to the site to make our testing more efficient. One of the other things that I'm sure you're aware of, you're reading a lot about, is the move to smaller, more fuel-efficient vehicles, electric vehicles, different forms of hybrids. So we've had to increase our technology in that area in terms of charging capabilities for these kind of vehicles.
My name is Steve Pratt. I'm a durability test engineer here at the Desert Proving Grounds in Yuma, Arizona. This is one of our test vehicles here. It's a new Chevrolet Volt, our electric car with extended range capabilities. The new Chevy Volt for 2011 was only available in 4 states initially. For 2012, it'll be kicked off and be available in all 50 states. This is an interesting vehicle. It's an electric vehicle, totally electric. Everything, the car runs on electricity all the time. It has a large battery in it that gives it about a 40-mile range for driving. And then when your battery is depleted, there's an onboard generator that generates electricity for the battery to keep the vehicle going for a longer period of time. It's got about a 350-mile range with battery and the gasoline generator. So it's a vehicle that can be used as your only vehicle for long trips, or it can be used for around town commuting. Here we have the charge plug here. Just plugs in and recharges the battery. There are 2 chargers that are available. There's a 220 volt charger, and there's also 110 volts, so it can plug into normal household current.
And very soon we're in the process of adding some high voltage chargers that will reduce that time even greater in the future. So it's a new cutting edge technology. We're happy to be part of it, happy to be putting on these types of additions.
We have about 120, about 80 GM, and the rest are contract employees. We contract out maintenance and security and our driving work.
I'm David Gerber, and I work here at the GM Proving Grounds in the Product Electronics Department. And I'm just showcasing here one of the several data acquisition system tools that we use here for gathering data on any of our vehicles here. And this tool I use to gather data and try and diagnose any vehicle drivability issues or electrical problems on the car. This is the exhaust, and so we don't want to, run the car in an enclosed building, and so this is a giant vacuum cleaner, if you will. It sucks the exhaust fumes out of this building and through a filter and puts it outside.
I'm Dale Balmer, and I'm a tester here at the Proving Grounds for General Motors, and a part of my job is to do infrared imaging. We do a number of tests. We'll image the floor of a vehicle to test the heat shields, how well the heat shields are made, if the coverage is adequate. We'll test the windshields, the defroster, the pattern of the defrosters on the windscreen. We can take an infrared camera and look at the result of the heat on the windscreen. Rotors on the brakes, we can measure exactly the temperature of the surface of the rotor. Infrared imaging, it can be used as a very accurate temperature measurement tool. What we would do is we would run a test to get it very hot. And it depends on the test. Every test has a performance has a standard or requirement that it needs to read. It needs to meet. The temperatures I see that are the hottest are 6 to 8 minutes after you turn the engine off, or if you come to an idle and let it set.
Hi, my name is Cheryl Clark. I'm a test engineer here at the Proving Ground, and I oversee drive quality testing. We have 12 different sub-tests that we run. It takes about 2 days to test a vehicle. I'm a data person, and I like this because I get all this data. I'm just fascinated by the fact that you can take a phenomenon and turn it into numbers.
We've also been able to partner with Arizona Western College here. We have an intern program that we do.
My name is Orlando Ramirez. I graduated from AWC last year. I started here in December 2010. I've been working here in durability, doing different type of tests, handling, tire shop. My favorite part of durability is working with other people building, testing cars. We drive them. We fix whatever the problem is, and pretty much I like working here at DPG.
Hi, my name is Henry Cannon. I'm currently a student at AWC, gonna finish my automotive degree here in December and hopefully get on full-time here at DPG. I'm currently working in the thermal area, and we're basically put devices on components to measure temperature in certain climates and stuff like that.
My name is Brandon Jones. I graduated from AWC earlier this year. I've been working here at DPG, and I enjoy it very much. I do brake testing, thermal testing. We instrument vehicles, drive them, and I very much enjoy it.
We're also working with the high schools. We had several of our engineers and technicians volunteer untold amounts of hours with the first robotics competition.
My name is Jason Burke. I work under Frank as a durability test engineer here at the Desert Proving Grounds in Yuma. What I'm standing next to here is our Haas Machining Center. We can make various parts out of billet aluminum, steel, just about anything you can think of we can machine on this machine. We primarily use it to make test parts for our vehicles and fixtures, that sort of stuff, to facilitate our test that we run here at the DPG. One of our projects this spring was our involvement in FIRST Robotics. FIRST stands for Inspiration and Recognition of Science and Technology. It's a nationwide competition that we participated in. The entire robot was built here at the DPG with involvement from 4 local area high schools. Basically, every part on this machine was fabricated on the Haas VF3 here.
My name's Alex Frias. I'm a durability test engineer. This spring, one of the projects we did with the community was FIRST Robotics. We built this robot within 6 weeks of build time and then competed in it and actually won the quality award the very first year out, which is pretty rare for a rookie team to do. Extracurricular, without grades, this is something they wanted to do, and we were glad to help out with that. So as you can see, JCPenney was also a sponsor, so they're really involved with us. Next year they'll be sponsoring us again, and we're hoping to bring in the first prize if we can. It's a cool little project that we did with the students, and that we're going to continue on this year.
Our workload here has been picking up steadily. We are primarily a hot weather test site. We're here for the heat. Just when the tourists all go home is when we get a lot of our visitors here to do testing.
This facility will attract hundreds of customers every year who will use the airport, rent cars, patronize local businesses, stay overnight in our hotel on a year-round basis, not just during the winter.
It will boost our hotel occupancy. It will get some people exposed to our community and spending dollars here in Yuma County.
GM's here for the long term. We have a 50-year lease with options to renew with the Army. And so what we're really trying to do is build a solid foundation that can last for a long time into the future.